Given that the roots of the equation x square plus 2x plus b is equal to 0 are real and differ by at most 2m, where m is not equals to 0, then b lies in the interval. So here they are real and differ by at most 2m means we can say roots are real and distinct. And if let us consider, let alpha comma beta be the roots of x square plus 2ax plus b is equal to 0, and so that the condition differ by at most 2m means alpha minus beta, given alpha minus beta must be less than or equals to 2m. So we don't know which is alpha is greater, beta is greater. So we need to apply the mod of alpha minus beta is less than or equals to 2m, and squaring on both sides. So we'll get alpha minus beta whole square is less than or equals to 4m square. Alpha minus beta whole square we can write as alpha plus beta whole square minus 4 times of alpha beta plus 2ab minus 4 minus 2ab will get. So which is less than or equals to 4m square. And also if alpha and beta are the roots, so sum of the roots is equal to minus b by a, that is minus 2a, and alpha beta is equal to c upon a, that is b. So we can write minus 2a whole square minus 4 into b is less than or equals to 4m square. That is 4a square minus 4b is less than or equals to 4m square, or we can write a square minus b is less than or equals to m square, or this can also be written a square minus m square less than or equals to b. So let us consider this as an equation 1. And the next one, and the next part, since the roots are real and distinct, so we can consider delta is greater than 0. So that is b square minus 4ac, that is 2a whole square minus 4 into 1 into b is greater than 0. That is 4a square minus 4b is greater than 0, or we can write a square minus b is greater than 0, or we can also simplify b minus a square is less than 0, so b is less than a square. Say this is second equation. So from 1 and 2, we can say b lies between a square minus m square is included and less than a square. So we can say that b belongs to a square minus m square closed interval comma a square is the open interval. So which is our option? B. Option B is the answer. We need to find the minimum value of mod z plus mod of z minus I. Since we have the property mod of z1 plus mod of z2 must be greater than or equals to mod of z1 plus z2. So and also mod of z value and equals to mod of negative z. So let us consider here mod of z minus I, which is equal to mod of negative of I minus z, which is equal to mod of I minus z. So we can write mod of z minus a as mod of I minus z, and let us simplify. Mod z plus mod of I minus z is greater than or equals to mod of z plus I minus z, that is equals to mod of z get cancelled, so I mod I value is equals to 1. So we can consider mod z plus mod of I minus z is greater than or equals to 1, and hence we can conclude that this expression is having the minimum value is 1. So minimum of mod z plus mod of z minus I is 1, which is our option B. Given alpha and beta are the roots of the equation x square plus px plus q is equal to 0, and omega is an imaginary cube root of unity, then we need to find the value of omega alpha plus omega square beta into omega square alpha plus omega beta. And here since alpha and beta are the roots, So sum of the roots we can write it as minus b by, that is minus p by 1, and product of the roots we can write c upon e, that is q by 1, which is equal to q. And also since omega is a imaginary cube root of unity, so we can have omega cube is equal to 1 and 1 plus omega square is equal to 0. So let us simplify. Omega alpha plus omega square beta into omega square alpha plus omega beta, which is equal to omega alpha into omega square alpha plus omega beta plus omega square beta into omega square alpha plus omega beta. So here we can add omega cube into alpha square plus omega square into alpha beta plus, and here omega power 4 into alpha beta plus, and omega cube into beta square. Since omega cube is 1, so omega power 4 we can write it as omega cube into omega, that is 1 into omega, which is omega. So omega power 4 I can write it as omega, and omega cube is 1. So 1 into alpha square, and here omega square alpha beta, and this is omega power 4 is omega alpha beta, and omega cube is 1. Or we can write alpha square plus beta square, alpha beta taken common, omega plus omega square. So we can write alpha square plus beta square. Since omega plus omega square, from here we can write minus 1. So we can, this is alpha beta into minus 1. So we can write this as alpha plus beta whole square minus 2 alpha beta, and again minus alpha beta. That is alpha plus beta whole square minus 3 times of alpha beta. Alpha plus beta value is minus p, so minus p whole square minus 3 times of alpha beta is q. So we can write p square minus 3q. So p square minus 3q, which is option D. D is the answer. We need to find the value of x power 4 minus 8x power 3 plus 18x square minus 8x plus 2 when x is equal to 2 plus root 3. When x is equal to 2 plus root 3, we can write x minus 2 is equal to root 3. Squaring on both sides, we'll get x minus 2 whole square is equal to root 3 whole square is 3. That is x square minus 4x plus 4 is equal to 3. Or we can write x square minus 4x plus 1 is equal to 0. Now let us divide this expression with x square minus 4x plus 1. X power 4 minus 8x power 3 plus 18x square minus 8x plus 2 is divided with x square minus 4x plus 1. So here x square times you will get x power 4. So let us consider here x square. So x square is multiplied with x square minus 4x plus 1. So we will get x power 4 minus 4x power 3 plus x square. So subtraction, we will get minus 8 plus 4 is negative 4x power 3, and 18 minus 1. So we'll get plus 17x square minus 8x. Now here we can see that x square minus 4x times you will get minus 4x power 3. So let us consider here minus 4x. So minus 4x must be multiplied with this. So we'll get minus 4x power 3 minus of minus plus 16x square and minus 4x. So here by subtraction we'll get 17 minus 16 1x square, and again here minus 8 plus 4 is minus 4x, and then plus 2. And now here again x square, so 1 times we will get, so 1 should be multiplied, so we'll get x square minus 4x plus 1. So we will be getting minus plus gets cancelled here, 2 minus 1 1. So we can write x power 4 minus 8x power 3 plus 18x square minus 8x plus 2 is equal to x square minus 4x plus 1 into quotient x square minus 4x plus 1 plus remainder is 1. So x square minus 4x plus 1 is 0. So 0 into here also, this is also same 0 plus 1. So 1 is the answer. So at x is equal to 2 plus root 3, the given expression value is 1, which is option B. We need to find the number of real roots of x plus 1 upon x whole power 3 plus x plus 1 upon x is equal to 0. And clearly we can mention that this equation x cannot be equal to 0. For x not equals to 0 and any real number, x plus 1 upon x by 2 is greater than or equals to under root of x into 1 upon x. Applying the arithmetic mean is greater than or equals to geometric mean of two numbers x and 1 upon x. So we can write this x plus 1 upon x is greater than or equals to 2 times of root of 1. That is x plus 1 upon x is greater than or equals to 2 or plus or minus 2 we can write. So from here we can say, so minus 2 and plus 2. So x plus 1 upon x either greater than or equals to 2 or less than or equals to minus 2. So for x is positive, for x is greater than 0, we will consider that x plus 1 upon x is greater than or equals to 2, and for x is less than 0, x plus 1 upon x is less than or equals to minus 2. So this is one general property. And now after simplifying, x plus 1 upon x taken common, so we'll get x plus 1 upon x whole square plus 1 is equal to 0. So in such a way that x plus 1 upon x must be equals to 0, or x plus 1 upon x whole square plus 1 is equal to 0. So x plus 1 upon x cannot be equal to 0 with the conditions for either x is positive or negative. So it is not possible. And x plus 1 upon x whole square is equal to negative 1 is also not possible. The square of any real number cannot be negative, and moreover it is greater than or equals to 2 or minus 2. So this is also not possible. So we can say that in both the case it is not possible. So there is no real root. So number of real roots are 0. Option A we can consider. For two complex numbers z1 and z2, given that argument of z1 conjugate, that is z1 bar is equal to argument of the z2, and we need to verify among these options which one is correct. So let us consider z1 bar, which is equal to, let us multiply and divide with z1, so that we can write 1 upon z1 into z1 bar, which is equal to mod z1 square into z1 inverse, that is z1 bar. Now apply argument for this. Argument of z1 bar is equal to argument of mod z1 square into z1 inverse. So it is something like argument of some constant into argument of some constant k into z1 inverse, where k is here positive we can consider. So argument of z1, it is given that argument of z2. So argument of z2 is equal to argument of k into some z1 inverse. So when comparing both here, we can say that z2 can be taken as some k into z1 inverse, where k is positive. So we can go with an option. We had first option z2 is equal to k into z1 inverse, where k is positive. So option A is the right answer.